The worksheet that you were given for line of best fit, I want to go over it very carefully with you, and you can check your answers as I go through. Number one, you have the time in hours and the remaining distance, and this is a bicyclist distance and time. So obviously, as time increases, your remaining distance is decreasing because you're traveling to a specific point. And they want to know in the question, what is an equation of the line of best fit? So obviously, the first thing I notice is this is going downhill. So it should have a slope that is negative. So I can get rid of this answer and this answer because they both have positive slopes. Next, I'm going to pick 2 points. Well, I also notice here they both have an approximate or 170 for a y-intercept, so both of those work out. So now we're just looking at the slope. We're trying to decide, is our slope negative 25 or negative 5 over 8? So I'm going to pick 2 points that are on crosshairs. And when I say crosshairs, this is what I mean. If you notice, as this line is going, it touches at certain points. Here is a good point. It's on a crosshair. And then if I continue to travel along the line, looks like this one is super, super close. So I'm going to pick that one as well. So these 2 points, I'm going to put them in a table. So this first point that I'm going to use is 2 and 120. And this other one is 4.5, and that would be a 60. So now let's do our humps over here and determine what's going on. This is a negative 60, and this is a plus 2.5. So if you take 60 and put it over, negative 60 over 2.5, is that closest to 5/8 or 25? Well, 60 divided by 2.5 is approximately 24, and it's negative. So obviously it's not 5/8. Obviously, choice number 1 is going to be A, negative 25, based off of the slope and the y-intercept. Here, number 2, we have wait staff earnings. This is the number of tables that they wait on, and this is their earnings in dollars. Pay close attention to your X and Y axis and what they're using to go up by. Like here, it looks like we're going up by 25s. Here, we're going up by every 2 lines is 250, so 125 every time. So we're looking again. Number 2 asks for an equation of a line. First thing I want to look for is the y-intercept. And if we look at our choices, our y-intercepts halfway in between 250 and 500 here would be about 375. So if I look at my choices, I'm going to get rid of this one and this one. And here, these 2 both work. And so now I just need to look at my slopes. So again, just like before, I'm going to pick 2 numbers or 2 points on a crosshair on the graph and make a table with them. I'm going to use this point, which is, go ahead and start making the table over here. This point that I just picked is at 75 on the X and 500 on the Y. And another point I'm going to pick is right here, and that's at 225 and 750. So if I go back over here and do my humps, I'm going up by 250 here, and I'm going up by 150 here. So changing Y's over changing X's is 250 over 150. And if I take 250 and put it over 150 and simplify that, that is 5/3. So if I look at my answer choices, again, number 2 is A. 5/3 is my slope. Here we have a theme park, and we're looking again, pay attention to these X and Y axis labels. Theme park attendance. As the temperature is going up, then the amount of people coming is going up. Now, we're trying to estimate, based on the trend line, how many would you expect for a temperature of around 80 degrees? Well, 80 degrees is here. We'll go all the way up so you can see where 80 degrees would fall. And since we already have a line drawn, I'm going to use a Post-it here as a sticky note. Try to line it up as best I can. Let's see if this gives us a good estimate. So I'm just going to draw that line, keep extending it, and see where it crosses that 80 degrees. It looks like it's about here. So if I go across, it's a little bit over 8, and this is in the thousands. So if you look at your choices, well, here's a trick for you. It's not 8. You have to pay attention to that thousands. So it looks like it's 8,300, a little bit over 8,000. Obviously, it's between 8 and 9,000 based on the graph. Number 4, the number of hours of sleep per cup of coffee. So if you have no coffee, it looks like this person's going to sleep about 8.5 hours. And the more coffee they drink, obviously it's caffeinated, they're getting less sleep, less hours of sleep. So we want to know a rate of change. So again, let's go back to the graph and pick 2 points on a crosshair, and it's based on the line of best fit. So here's a point. Looks like it's on a crosshair. And I'm actually going to go all the way down to this point on the line. And let's make a table. A trusty table for 2 hours of, 2 cups of coffee. That's 7 hours of sleep. And 9 cups of coffee, oh my goodness, I would not sleep at all, is 2 hours of sleep. So here we're going down by 5. And here we're going up by 7. So if we did that as a fraction, it would be negative 5/7. Change in y's over change in x's. Negative 5/7 for your rate of change. Number 5, cost of a cell phone bill based on your number of minutes. And this is not a flat rate, obviously. The more you talked on this or the more minutes you used, then the more your bill's going up in the amount of dollars. So they're trying to find the equation of the line of best fit. So let's first look for our y-intercept. It's the first thing we can look for. It's at 15. So if you look at your answer choices, let's get rid of this one and get rid of this one. These two are good options because they both cross the y-axis at 15. So now let's pick 2 points on a crosshair. Looks like this one's a good one. If I go ahead and make my table, this point is on the line, obviously, at 0.15. So that means if you don't talk at all, it costs $15 for the bill. So obviously that's your flat rate of $15. And then another point I'm going to pick is here. So if you talk 600 minutes, it would be $30. So if I do my humps, I'm going up $15 per every 600 minutes. So that would be 15 over 600. And 15 over 600 reduced is 1 over 40 for your slope. So 1 over 40 is here. Choice D. 5 is D. 1 over 40 is 0.025. So basically that's 2.5 cents. So I would write this as 2.5x plus 15. This is in cents. So actually it would probably be better to do 0.025 and actually put the cents in there. That's like $2.5. So that's probably not a good idea. That would be your equation. The 140, I just changed 1 over 40 to money, make it a little more realistic. But that was number 5, and it was D. Number 6, the weight gain according to water consumption. So the more water a person drinks in a day, the amount of weight that they gain decreases. So is drinking water a good thing for weight? Yes. So we're looking for the correlation. So as your x's increase, I'm just going to put a little guide over here for myself. As my x's increase, my y's are decreasing. So I'm going to look at my answer choices. This says as my y's increase, my x's increase. Well, no, that's both of them going up. Y is obviously not constant. This says they're both going down. Here, if the y's decreases, the x's increases. That's what we're talking about. So 6 is D. 7, notice I made a table of those values. And the easy thing with this one is there was only 1, 2, 3, 4, 5, 6 points. So that's not too bad to do. And it's talking about absences and a final grade. So what I want to do with this is show you how I would plot those points on the graphing calculator. So I'm going to switch screens to Desmos and show you how I would do this in Desmos. So first of all, I would add a table, and I'm just taking those table of values that you just saw from the chart. It's a 0, 1, 2, 3, 4, and 5. And then the y values are 95. That means a person with 0 absences would be expected to have a 95 average. Then it goes to an 85 with 1, back up to a 90, so it's not perfectly linear. Here we have an 80, a 70, and a 75. So I do not see these points yet because my y values are so big. So I'm going to have to decrease my screen a little bit so I can start seeing it. And here's what I'm seeing. So I can zoom in, zoom out till I can see those points. So it's a very negative line. You could change your scale if you wanted to. For the purpose of this, we don't necessarily have to do that. I can now calculate what the line of best fit equation would be. We type in y1 is approximately m times x1 plus b. And there's my equation. And there's the line of best fit. So I can actually put in that line of best fit. Now I'm going to use your M and D right here and right here. And I could, let's see here, negative 4.42857 x plus the B, 93.5714. That is my equation. So the cool thing about that is, watch very carefully, I can click on this little gear shift up at the top, and now I want to take that equation and actually put it into a table. Now, why would I want to do that? Because if you look back at the question says, what would you predict if you had 7 absences? So where x equals 7, we want to know what the y would be. So I can do that right there on that table. Click on here. I've got the equation in there, so I can just plot 7, and there we go. Our answer would be 62.57, and it's closest to 60, approximately 60. So number 7 would be D. Again, that Desmos calculator came in very handy for that one. Number 8, we're looking for the scatter plot with the most likely line of best fit of a negative 2x plus 1. So if you have a negative 2x plus 1, that means we're going downhill. So let's look at our points for these. Is this an overall downhill? Yes, so that's a possibility. These are, looks like they're going uphill, so I can get rid of that one. Here, overall downhill, yes. This is overall going uphill, so no. So basically we're looking at this graph, W, or this graph, Y. So I would guess the easiest thing to do would be to go back to Desmos and put that in the calculator and see what it looks like. So I'm going to go back to Desmos, and I'm going to start a new graph. And I'm going to type in y equals negative 2x plus 1. And let's make that into a table to get some values. So for this table of values and I'm looking back at the worksheet, for the value of negative 2, I should be at 5. So negative 2, I should be at about 5. And then for 0, I should be at about 1. And for, let's see, 2, I should be at negative 3. And so forth. And so the graph that looks the best to me, I'm going to go back here. Notice this is fairly steep. Here's the point. We'll keep going a little bit. Let's see, negative 4. Negative 4. Looks like it's almost close to 10. Okay, so it should be more steep than that. My guess is Y. Looks like this one goes through the most, catches the most points. So the answer for number 8 would be C. Number 9, here we have a lawn service. Obviously, the more lawns or yards someone mows, the more money they're going to make. So we're looking for the equation of the line of best fit. First off, I'm going to notice my y-intercept is at 0. So if I look at my choices, we obviously don't start out at 300 without mowing anything. So these two are our options at this point. So now let's find another point on a crosshair to work with. Here's one. There's another one. There's another one. So basically our slope is we're going rise over run. We rose to 300 and run 10. Well, 300 over 10 equals 30. So that's your slope, 30x, choice B. Number 9 is B, rise over run. Number 10, use car value from the time that you purchase it. Obviously, we're starting out. This is in thousands of dollars. So we're looking at if you started out and purchased a used car and paid $11,000, over time, the value of that car is going to go downhill or decrease. So our y-intercept is 11,000. So again, look, they tried to trick you. It's not 11, it's 11,000. So these two are options. This one is out. So let's pick another point to do our rise over run. Look for a crosshair. There's one. It's on a crosshair there. So I'm going to pick my 2 points and put them in a table. The first one is 0, 11,000. And this one is 4 years. It goes down to 8,000. So basically we dropped $3,000 in value over 4 years. So 3,000 divided by 4, and obviously it's negative. 3,000 divided by 4 is $750, and it is negative. Choice is A. For every year, it's dropping $750. I'm sorry. Not A. A didn't work. It's B. B, negative 750. If we started this, for this particular graph, you purchased a car for $11,000, and for every year, it's dropping a value of $750. That's number 10. The answer is B. 11, we're almost done. Here we can do another line again, so we can estimate when 30 students visited. So I'm going to just continue that line with my sticky note. You could plot those points on a graph if you wanted to and use Desmos. Since I have a paper copy, it's kind of neat to just go here. And it looks like it's between 120 and 150. So we look at our answer choices, and that would be C. 11 is C. Now, you could have picked 2 points here and about here and found the slope and the y-intercept and got an equation. You could have done this a variety of ways, but and then just plugged in 30 for x. That would have worked as well. 12, both of these are increasing. As x goes up, y goes up. So the only one where both of them are the same, going up, is B. Increase, increase. Now, it would have been okay for it to say as y decreases, x decreases, because that's the same thing as both of them increasing. But number 12 is B. Here, we're looking at computer time spent on the computer versus TV. Obviously, the more time you spend on the computer, the less time you're spending watching TV. So how much time does a teenager spend watching television if they spend 120 minutes on the computer? 120 minutes on the computer is about here. I'm going to trace that out. And it is, let's see, this point in between here would be 160. So it's a little bit over 160. So the answer would be C. 13 is C. Almost done. 14, I made a chart already. I made the table. So I'm going to go back to Desmos here. And I'm going to make a new table. So create a table here. Let's plot those in. So we have 0, 0.5, 1, 1.5, 2, 2.5. And then my y values were 20, 20 again, 30, 60, 70, and 70. So this is our studied and exam data for the grade for an exam. So I'm going to click here and let's get the equation for that. So I'm going to put y1 is approximately m times x1. Always put that 1 in there, plus b. So there's your equation. So I'm going to type in the actual equation now. Y equals 24.5714x plus 14.2857. There's the equation. Can't see it very good. Looking for those points. Looks like about there. And the neat thing about this now is I'm going to click on the gear, turn it back into a table, and now I can plug in the value that they wanted me to find. Back in the problem, it was 3.5. So 3.5 looks like they're going to make about 100. So if I look at my answer choices, the answer choice would be B. Number 14, B. And then 15, last one, the units sold in hundreds. So this is how many hundreds that you did. So my y-intercept is 40. So if I look at my answer choices, I can get rid of this and this. And now let's pick some points. That first point that I just used is 0.40. And then another one on a crosshair, there's a good one. That's 400, be careful, and 32. So I just dropped 8 and gained 400. So if I do -8 over 400, is that closest to 1/50th or 1/2? Well, obviously 8 over 400 is about 1/50th. -150. Answer choice B, that is number 15. Make sure that you stop this if you need to, rewatch, take notes, check your answers, and hopefully this will help you for your next exam.